Hi friends, now we are going to see area related to circles. The sum based on finding the area of the shaded region. Let's take this different shaded region. Okay, this is the diagram what you have here. It is a right angle triangle because the semicircle. When you take a semicircle QR or RQ, in the RQ there is a semicircle. Okay, in the adjoining figure, PR, PR is 6 units and PQ is 8 units. Semicircles are drawn taking the sides PQ, PR, RQ, PQ as the diameter. Find the area of shaded region. So shaded region, so here we have shaded region 2 and as well as the triangle, area of triangle we have to add. This is also shaded region. So now we have to think about how to find the shaded region. It is very simple. First you have to take area of semicircle as diameter. PR is the diameter, the full area will get. Okay, the full area. PR is the diameter, you can take area of semicircle, and PQ is the another semicircle. That area you can take fully. Full area we can take. But we have to subtract these two areas. We can't find these two areas. Okay, it is not a sector, it is segment. We can't find area of segment now, but the whole area where RQ area, no, the full RQ area we can subtract. When you subtract RQ area, these two only we have to subtract. This triangle we should not subtract. Triangle also shaded region, so we have to add the area of triangle. So now, what is the shaded area? First take area of semicircle where PR is the diameter plus PQ is the diameter, add the area of this semicircle. Then area of triangle we have to add. Okay, now we have to subtract the entire area of semicircle RQ semicircle area should be subtracted. That's all. By seeing this idea, we can solve that. Now, how to find area of semicircle, sir? If you want, you should know the radius. What is the radius? That you have to think. So now, when it go with the PR, diameter is 6, so radius is 3. When PQ, diameter is 8, so radius is 4. What about RQ, sir? RQ diameter. RQ diameter is not given. How to find? It is a semicircle. When it is a semicircle, so this angle should be 90 degree. Angle at P, 90 degree. Because angles in the semicircle is 90 degree. So it is right angle triangle. We can call Bordhaina result or Pythagoras result. So sum of squares of other two sides is the square of the hypotenuse. So now RQ is the hypotenuse. So using that right angle triangle PQR, angle at P is 90 degree. So we can use hypotenuse square. Hypotenuse is opposite to angle 90 degrees hypotenuse, which is equal to sum of squares of other two sides. Okay, Pythagorean result we can apply. So 6 square plus 8 square, that we can find. Okay, 6 square is 36, 64, 100 is the total and square root is 10. Diameter is 10. What is the radius of the big semicircle? 5 is the radius. Now I know that you can solve this problem very easy. That's all. Now concept area is over. How to find the area? This shaded region, blue region, and this blue and this region we have to add. So first use the semicircle formula 3 times and one area formula. How to find area of triangle? Half into base into height. Which is your base? Since it is right angle triangle, we can take 4 is the base and 3 is the height, or 3 is the base, 4 is the 8 is the, I'm sorry, 8 and 6 are the adjacent side. That is arms of right angle triangle. So either 8 is the base, 6 is the height, or 6 is the base, 8 is the height. Like that we can use it. So we can find the area of the triangle. Half into base into height. Okay, good. That's all. Now we can solve this problem. So my duty to complete your idea. Whatever the pictures you have, what idea we have to apply. Okay. And after the problem, you can know that there is a fantastic understanding with that result. Now area of triangle is 24 square units. Okay, keep in your mind area of triangle is 24 square units. Now what is our duty? Now area of semicircle, two semicircle you have to add, one semicircle you have to subtract. So that is the final steps. So when you go with the semicircle formula of pi r square, so now we can take half pi common, we can take so r1 square plus r2 square minus r3 square, that is 3 square plus 4 square minus 5 square. What is 3 square plus 4 square? It's 25 minus 25. So it is clearly says that 0 pi, correct? That means the 24 is the result. Through that, what is your understanding? See that area of semicircle. Okay, the area of semicircle, big semicircle is equal to area of the two small semicircle. That is the meaning. Already we have seen that. So shaded region, this crescent, PR crescent and PQ crescent, and the area of triangle is nothing but 24 units only. So area of the shaded region is 24 units. I think you will understand that problem. It's a very best result we have taken now. Now, let's come to the next question. Here we are going to deal with some sector. This is somewhat, we have segment PQ and PR. There are some segment. So now we have to find this area of segment. Two segments are there. How to find, sir? You take area of semicircle where QR is the diameter. Take the semicircle area. Then you have to subtract the area of the triangle. That's all. If you subtract the area of triangle, automatically these two segment areas we can find. So this is a basic idea behind this problem. And they have given PQ. PQ is one chord, 24, and PR is another 7. So I already said this is right angle triangle. Why? Because that angle in the semicircle should be 90 degree. Angle at P is 90 degree. So we can find this QR. Once you find the diameter, then only we can find the area of the semicircle. So our duty to find QR is what? So how to find shaded region? Area of semicircle minus area of triangle, so that we can get the shaded region area. So RQ is the diameter. To find the diameter, you have to use the semicircle concept. So angle at P is 90 degree, right angle triangle. Now we have to use this Pythagorean result or Bodhana result. Okay. So we know that how to find area of triangle half into base into height. What is your base? Either 24 or 7. Height is alternative arms of the right angle triangle. So finding the area of triangle is very simple. Okay, that you keep in your mind because that you have to subtract 84 square centimeter square. You have to subtract from area of semicircle. But if you want to find area of semicircle, the formula is half pi r square. So we need radius. So radius means first we have to find the diameter. This QR diameter we have to find. So how to find QR diameter? Use the formula of uh, Pythagorean result. So 7 square and plus 24 square. How much? 625. Square root of that is 25. So diameter is 25. We can take radius is 25 by 2. So with that concept, we can find the area of semicircle. Okay, we can find area of semicircle. After that, we have to subtract this area of triangle already we find. That's all. This is the concept of this problem. So first you have to find area of semicircle minus area of triangle. That will give the shaded portion. Shall we take next problem? Now see the figure. Some ABCD. Okay, it's a square. In that something is taken out. So something. What is that? Semicircle. Two semicircle is taken out. The remaining area is left out. Okay. And my suggestion now, if you take two semicircle together, it becomes circle. So it's very clear that in the area of square, we have to take 2 times semicircle or area of circle. If we subtract area of circle from the area of square, we can get the left out area, a shaded region. That's all. Concept is very simple. Then the side is 14 centimeter, which is the diameter of the semicircle. So radius should be 7, correct? So now you have to find area of square. You have to subtract area of semicircle 2 times. Or semicircle 2 times is nothing but area of circle. That's all. It is very simple. What is the area formula to find square? Side square. So 14 into 14 will give 196 is the area of the square, and now you have to subtract area of semicircles 2 times. So when you talk 2 times area of semicircle, it is area of circle only. So we have to find the radius is 7 because diameter is 14. So the side 14 is the diameter. Now what is the radius? Half of that 7. Through that we can find area of, so 2 semicircle is 154. If you subtract 154 from area of square, you can get that the remaining shaded region 42 centimeter square. Now I think you will catch the concept. So we always need mathematical eye. Whatever the pictures we have seen, in that we should try to find our mathematical shape. What shape is available? Like that you have to see. So really it's a wonderful problem. On the square handkerchief, 9 circular designs, each of radius 7 centimeter are made. Find the area of remaining portion of the handkerchief. Okay, so very interesting. So remaining area, how to find remaining area? Okay, that will be pink in color. Okay, how to find it? So you have to find area of circle where radius is 7 centimeter into 9 times. So 9 circles are there. It may be made with some design, some woolen designs they may make like that. So we have to find remaining areas. How to find remaining area? Area of square minus 9 times area of that design circle. That's all. It's very simple. How to find area of square? Side square. So what is your side? No, side is not given. Here only radius of the 9. So radius means diameter 14. 3 circles are there. So 3 times 14 should be added. That's all. If you add 3 diameter of the circle, that is the side of the square. So radius is 7, diameter is 14. Add 14 3 times. Okay, that will give your side of the square. So here we have find the side of the square is 42. So 42 square, that will be the answer for area of square. We want to find remaining area after take out the 9 circular designs. So we have to find area of circle 9 times. Okay, pi r square. R is 7. It's very simple. To find 154 is 1 circle area. We have to multiply by 9. So 9 circle area. Please to be subtract this one from square. Then we can get the remaining portion in the handkerchief. So I think you understand the concept how to do the problem. It's quite interesting. Thank you dear students for your appreciation. Let me go with next problem. In a circular table, radius 32 centimeter, a design is formed leaving an equilateral triangle ABC. So this is a circular table, maybe some circular table. Here the design is made by leaving the equilateral triangle portions. Okay, and what is the area of the design? So very simple, area of circle minus area of triangle, that's all. So if you want to find the area of the design, that is nothing but first you have to find area of circle. Area of circle radius is given 32 centimeters, so it is not easy. It is easy to find area of circle, but we have to subtract area of triangle. So area of circle is, you know that formula pi r square. So finding area of circle is very easy for you dear students. I know that. But the problem with how to find area of triangle. So finding area of triangle, we know only one formula, half into base into height. What is the base here? What is your height? Oh, this is equilateral triangle. For equilateral triangle, there is another special formula is there. Root 3 by 4 into side square. But if you want to do that, you should know the side. Okay. How to do the side, dear students? How to do the side? Now think about that, because 32 is not a side. We have to find the side. For that, we need some more ideas. What ideas? First, A, from A, we have to draw one line and find that is a perpendicular line AD, that is our altitude. So we have to find altitude first. In an equilateral triangle, altitude, equilateral triangle, we have to say centroid, altitude, both are same. Centroid is nothing but midpoint. A line pass through the midpoint. D is the midpoint of BC. So if a line pass through the midpoint from the vertex is called centroid. Okay, that is median. Median also will pass through the same altitudes. Concurrency of altitude and centroids, medians are the same point. That is centroid. Centroid is the point. Okay, it's a collinear. AID is a collinear. So now that's a ratio. We have that 2 is to 1. When you talk about medians, concurrency of median should be in 2 is to 1 ratio. Okay. So with the 2 is to 1 ratio, 2 times 32. So what is 1 time? So we can find altitude very simple. If 2 times is 32 divided by 2, which is 16. So 1 time is 60. So very simple to find that. So 2/3 of the AD. So this is very simple. Divide 32 by 2, that is 16. So DI is 16. So from that idea, altitude we can find very simple. Altitude is 32 plus 60. That is your altitude. So what is your altitude? 30 plus 16, 48 is the height of the equilateral triangle. Once you know the height of the equilateral triangle, you can find other two sides. So here the problem is finding the area of triangle. Since it is a equilateral triangle, we have to find the side. What is the side length? Okay. Now we can take the triangle ABD is the triangle. In the triangle, equilateral triangle means all the angles should be equal. So what is your angle? 60 degree. Here angle B also 60 degree. Now we know trigonometric result. Correct. We want opposite side. AB we want. So what ratio we can apply? Angle 60 degree. We know that. Opposite side, which is 48 centimeter. Opposite side AD is 48 centimeter. We know opposite side. We know the angle. We want hypotenuse. So what ratio we can apply? Yes, you are correct. Sin theta is deal with the opposite side and hypotenuse. So use sin 60 degree equal to AD by AB. Exactly correct. So what is AD? Now only we find 48. And sin 60 is root 3 by 2. Then AB easily we can find, that is your side. What is your AB? 48 into 2 by root 3, that is your AB. Okay, now one side we know that. So to rationalizing denominator, multiply by root 3 by root 3. So now 3 can cancel with the, so 32 root 3 is the side of the triangle. Now equilateral triangle area, what is your formula for equilateral triangle? Root 3 by 4 into side square. So what is your side? Now only we find side square is 32 root 3 whole square. So now we have to cancel everything. Root 32 into 32, root 3 become 3. That's all. By cancelling everything, we can find the area of triangle. Now subtract area of triangle from area of circle. So that is your left out designing area. That's all, dear students. Here finding the area of triangle, only radius is given. If radius is given, how to find area of triangle? Now we have learned that. Correct? Good. Let's see the next problem. Here, see the adjoint figure. It is triangle. Inside the triangle, we have circle. So ABCD is a right angle triangle. So right angle at angle A. They have given like that. Now area of shaded region AB 6 centimeter, BC 10 centimeter, and we can find other side also. That is not problem for us. I is the center of the incircle. That is incircle we have that angle bisector. If you make angle bisector, we can have the incircle I. Okay, that is our concept. Now in a right angle triangle, two sides we know that opposite to 90 degree is hypotenuse. Automatically we can find other side also. That is not problem for us to find side AC. Now area of triangle we have to find. If you want to find area of triangle, half into base into height. So base height should be the adjacent arms of the right angle. So we want AB and AC. If you know AB and AC, then we can find area of triangle. Next we want the radius of the circle. If you know radius of the circle, then we can find area of the circle, we can subtract. So here challenging is to find area of circle. Area of triangle is very simple because that AC we can find with the help of Pythagorean formula, correct? So here area of triangle minus area of circle. First how to find area of triangle? Half into base into height, the product of perpendicular sides. The product of perpendicular sides, one side we know that 6 centimeter. What is your another side? AC. Since it's a right angle triangle, the hypotenuse is BC. So BC square equal to AB square plus AC square. Then 10 square equal to 6 square. Okay, then what is that? So we have to subtract from 10 square 100 minus 36. That's 64. The square root of 64 is 8. So AC is 8. Now finding area of triangle is become very simple. Correct? We can find area of triangle. Good. But area of circle, we have to find first radius of the circle. Here finding radius of the circle, we have to think how to find radius of the circle. Okay. And I know that if you put a perpendicular line from the center, it should be perpendicular line. Okay, because the tangent always, BC is the tangent always perpendicular to that base. So that is very important result. So by the way, if you draw like that, we have so many isosceles triangles, correct? And one more thing, the length of tangents always equal. Okay, with that concept we are going to find the radius. So now triangle divided into three equal parts. Okay, ABC divided into three triangles. Good. So half into base into height. Here base 10 centimeter, height is R. Correct? Half into base into height. So half into base 10, height R. Next side base 8, height R. Next side base 6, height R. So here R we can take common. Take R is the common. Now BC plus AC plus AB, perimeter of the triangle. By adding everything, we can get 20, 10 plus 8 plus 6, 24. So now we can find the radius is equal to 2. After finding radius 2, again you can come back to the area of circle of pi r square. So r is 2. That's all. Now we find the area of circle. We have to subtract area of circle from area of triangle, which will give shaded region. I think you will understand that problem. Let's see last problem. See the figure. There are two circles. Okay. The crescent is formed by two circles which touch A. Correct? The larger circle. C is the center for larger circle. Okay. BD is 9 centimeters given. So BD is 9 centimeter. This area. This is BD length. Okay. And EF is 5 centimeter. They have given. but we want radius of big circle and small circle. Okay, how to find this? This breadth is 9 and this is 5. So we have to find out radius of two circles. Okay, how to find areas of two circles? After that, we have to find shaded. Shaded region is very simple. Area of the big circle minus area of the small circle. It's very simple. But with this information, 9 centimeter and 5 centimeter, BD and EF, how to find the radius? We have to draw AE from A to E and DE. If you draw it like that, it is a semicircle. Now, one thing is very clear, the semicircle make a 90 degree at angle E. Okay. When you take a smaller circle, it is a diameter, DA is a diameter. Okay. And this is 90 degree. Angles in the semicircle, angle E is 90 degree. DEC, let it be theta. Take the small triangle of DEC. This is your theta. That AED, that's sum of AED is made up of DEC and AEC. Sum of these two angles is 90 degree. So each one is complement. AED, which is equal to sum of these two angles, which is 90 degree. So each angle is complementary. If you want AEC angle, you have to put 90 minus theta. This is your result, AEC. DCE. DCE is a triangle. That is a theta. So now my role now we are going to say that similar triangle. So here angle D also 90 minus, this also 90 minus theta, and here AEC also 90 minus theta. So let's take two triangles ECA. So by this result we can tell about two triangles are similar. When two triangles are similar, we have to use similarity, correct? AA criteria, these two triangles are similar. When you come to similarity, then we can raise the ratio of the sides. So two triangles are similar, then we can write DCE is similar to ECA. So we can write DC by EC equal to EC by CA, because corresponding sides of the similarity triangles. So corresponding CSST, corresponding sides of the similar triangle, we can get the result. Then you have to DC. So this is first two letter of the triangle, DC by EC. First two letter of the next triangle. Then EC, that is the next two letter of the triangle, and CA is the next two letter of the triangle. These ratios are equal by similarity. Now EC cross multiply. So what is EC square? CA into DC. Okay. So this is the result we got. By the way, we are telling that two triangles are similar. Now come to our radius of the big triangle. BC is the radius of the big circle, which is BD plus DC. So BD plus DC equal to BC. Now DC. How to find DC? The capital radius minus R. That is your DC. And CA. Now CE. When you talk about CE, that is capital radius minus that 5 centimeter, that is your C. With the help of that, we can find these radius, two radius we can find. R minus 9, you have to multiply. So here R minus 9, R minus 5. If you multiply these two from that triangle, we can find that radius. Okay, after finding the radius, we can complete the two radius of the triangle. Then we can complete this area of the region. Thank you, dear students.